Optiva is a global market maker. We provide liquidity in tens of thousands of financial products on major exchanges all around the world. Our engineers work to understand technology deeply and find simple solutions to complex problems, and Python is the perfect tool for that.
Our mission to connect 1 million creators with 1 billion fans is a huge challenge, but using the Google Cloud Platform is an easy and scalable way to unlock our own innovation and really made it the right choice for us.
Hello there, we are back. So yeah, I hope you have a great lunch, and I hope that you're enjoying so far. And actually, I had a lot of food left over from yesterday's cooking show, so that's my lunch. But anyway, because all of you are refreshed, we'll have our next speaker, which is Vinicius. Did I pronounce your name correctly?
Yeah, that's okay. It's Vinicius. It changes according to the country.
Yeah, yeah, it's difficult for me, because I only speak English and Chinese, of course. But yeah, so you're going to talk about the anti-patterns in Python, which is very interesting. So I will let you take us away then.
Great. Let me just reset my timer. All right, let's do it. I'll be presenting now about Python anti-designed patterns, specifically what we should not do with our code. For anybody who doesn't know me, my name is Vinicius Gubiani Ferreira. I'm a senior backend developer at Asion Technologies for about 3.5 years now. Asion is a serverless and edge computing company dedicated to making the web faster and safer. I recommend you guys check our website after this presentation. Recently, I started working with the quality assurance area for about 3 months now. And also I'm an open source contributor. I work on a daily basis translating the Python documentation for Brazilian Portuguese. And I also love craft beer and riding a shared bike around the park. Both, I believe, are environmentally friendly. So our schedule for today, for this presentation, is pretty simple. It's mostly the motivation for this talk about generic anti-patterns, and then specific Python anti-patterns. So about the motivation, it's mostly to help you guys reach the next level. For anybody who is starting with Python or consider themselves intermediate level Python programmers, to improve their code, to make it easier to maintain, to refactor, to read, and to speed up code reviews. We have several guidelines, such as PEP 8, PEP 20, PyLint, that for some time when we have, for example, an emergency situation, we have to bypass, to ignore, and they don't cover everything that is necessary to have good code. So this presentation is mostly trying to expand beyond just our basic guidelines. So speaking about generic anti-patterns that apply to any specific language, not just Python. So before anti-patterns, let's quickly recap into patterns themselves. So what exactly is a pattern anyway, or a design pattern? It's mostly a common solution to a recurring problem. It happens at least 3 times with different teams without any contact at all among them. Ends up being widely adopted. Can be considered as a convergency methodology, and is also very reliable and effective. The anti-pattern, on the other hand, looks great when we start, until it's not anymore. When you usually start with an anti-pattern, it all looks like an awesome field filled with beautiful trees and flowers, when things suddenly can go wrong very bad, very quickly, like if you're actually in a maze with monsters. And sometimes it often causes more damage than the original problem itself. We started to wonder, maybe we shouldn't have done that after all. They usually belong to one of 3 large categories that are proposed by this book, which surprisingly was one of the few books I could find regarding anti-patterns. I recommend you guys check it out. It's also on the references for the slides. The categories are development, architecture, and project management. Since we're not going to be able to cover all of the anti-patterns, the book have lots of them, I picked just a few of them over here for discussion. And let's start with Bolt Anchor. Bolt Anchor, it's usually a piece of software that serves no purpose at all. I actually knew this anti-pattern and refer to it as zombie code, which is code is actually dead and is not doing nothing except trying to eat your brain out, figuring out what the code does. And the answer is nothing. The book proposes several approaches for correcting those anti-patterns. And for this one, the solution is to get rid of the code as soon as possible. And I know it's actually easier to say than do, but that is a solution. This one, lots of people probably heard about it, is the spaghetti code, which is software that is very untangled with no structure or clarity. And it's hard to work on that. And even on projects where there is a lead developer, a core developer, or a single developer, if that person stays away from the code for some time, for example, go on vacation, then you have a hard time into trying to pick up the flow of the code. And the solution for this one is to refactor, to clean up, to organize it. We also have the God object, which, unlike the spaghetti code, does have some structure, but unfortunately it doesn't mean it's a good structure. It's very easy to spot the God object because you can see it from 1,000 miles away. Usually it's like a project with a single file, or maybe a class with 300, 3,000, 4,000, 5,000 lines of code, or a little method that you crafted so carefully, but unfortunately it now has 300 or 400 lines of code. So the solution for this one is to split it up into less responsibilities that are easier to maintain. And speaking about responsibilities, everybody heard about vendor lock-in. This is a pattern when our code or solution or product relies too much on a specific vendor, and for any specific reason we decide that we don't want to use that vendor anymore. Let's say the company is going out of business, or the dollar currency just skyrocket and we don't want to transfer our costs for the clients. Then if we're actually trying to remove that code from the third party and didn't plan accordingly, then we are probably in for one hell of a party. It's going to be awesome. And the solution for this one is usually to place an abstraction layer in front of the third-party solution, like an API, for example. Then we only have to care about the interfaces themselves, and we can literally just change the engine under the hood, and that's it. We don't have to care about anything else. We also have cargo code programming, which is pretty much like following a solution or a piece of code blindly and not understanding what does it do or how does it work. I'll also refer to this one myself as Stack Overflow programming, which is something like, hey, found an awesome code on the internet that just solves my problem. How does it work? Don't know, don't care, move along. No, we should not do that. We should actually aim to understand what any code that we're using does. Everybody heard or will heard once about premature optimization. There's a famous quote that says it's the root of all evil. And in fact, 97% of the time we don't have to optimize our code, but we can't pass those 3% where we do have to optimize the code. And the solution for this one is to plan our code, to design, to implement, and after that, profile, benchmark, and load test it. Then the 3% that have to be optimized will show up. If we optimize prematurely, then we're going to make our codes unnecessarily complicated. We also have magic numbers, which why do we think they are magic? Because they seem totally random, and if we actually change them for any specific reason, since there are no explanation why we picked those numbers, then we're going to have too many weird errors and problems. So the solution for this one, there are two possible solutions. Either a comment explaining what that number does, Or better yet, just define a constant in a constants.py file and use it where the constant was. And finally, we have gold plating, which is to continue to work on a task beyond the point that it doesn't deliver any visible value to the customer or to the company. And the solution for this one might be annoying for some, is meetings. Meetings with your boss, with the product owner, with the client, with your fellow peer developers. For some people might be annoying, but turns out during pandemic times, it's actually good to speak to other people every now and then. So we should try that. So moving on to Python specific anti-patterns. There's a book with a very good descriptive name. It's the Little Book of Python Anti-Patterns. It is an awesome work created and published under Creative Commons license by Quantified Code, a German-based startup. Since it uses that license, we can download it and read and distribute it for free. The link's available at the end of this presentation. And just like the other book, it suggests 6 large categories, which are correctness, talk about all the things that shouldn't break our code, maintainability, everything that will give us a hard time to change the code in the future. Readability is all about making the code easier to read and to understand. Performance is everything that will slow us down. Security is all about threats. And finally, migrations is all about upgrading our Python package versions. So again, there's not going to be enough time to discuss all the anti-patterns, so I picked the ones that I thought were most relevant. We'll be focusing mostly on correctness, maintainability, and readability. Let's start with this one, which is probably the worst anti-pattern I found. There's a specific link dedicated to just this anti-pattern at the end of this presentation, which is to not specify exception when we are using try except. I actually knew this one a long time ago as Pokemon catch exception, which is to catch them all. So let's assume it's okay, which is not to catch all the exceptions at once with a single except. And what we should definitely not do is just pass, move along, like if nothing happened, everything is fine, I just recovered from an exception. No, we should definitely not do that. We should actually log what's going on to help other people understand what's going on. Otherwise, clients might be in trouble, and we're not aware about that. And preferably, we should try to catch specific exceptions instead of the generic ones. Ignoring context managers for handling files. When we're opening files for read and write, we can have any error with our Python code. For this example, I'm forcing a division by 0 on purpose, of course. And if we didn't write the data to the files, we might either lose data or, even worse, get the file corrupted, and we're going to lose all its data. So to solve that, we have context managers, which is the with instruction on the right. And what does it do? If we have any problem at all, like an error, then the context manager will still call the _exit method, which will be responsible for writing to the file, closing it, and free any resources, the memory itself. One bad anti-pattern is to return more than one variable type. In this example, we're returning none and a string in the same time on the left. This usually and sometimes give birth to code that is hard to maintain, to test. So a better idea is just to stick with a single variable type. And if we can't do that, maybe just raise an exception for the other cases. Accessing protected members from outside the class. Python is a very permissive language. It allows us to do many awesome things, but sometimes a good thumbs up rule is just because we can doesn't mean we should. And in this particular case, we are accessing protected members from outside the class. The correct way, since they are supposed to be protected, is to implement public interfaces like the getter and setter methods. Assigning to Python built-in functions. This is bad, really, really bad. Why so? First of all, because we're not going to be able to create new lists using the list built-in function from Python. And second, because it hurts our debugging capabilities. I myself use the Python debugger, the PDB. So I stumbled upon code very similar to this, which I couldn't get more lines on top and below the current line. So it was hard to debug. And what we should do in these cases is to give more meaningful names that describes our variables or methods. That is the correct approach. Mixing tabs with spaces is an also bad anti-pattern. This is actually very easy to fix with our IDE. So I'm not particularly sure why people most times prefer tabs. Maybe they forget, I don't know. And the reason we should actually use spaces is due to the PEP8 convention that obliges is, well, it's not oblige, but enforces, requests us to use spaces. And if you're not actually satisfied by just, there's a rule that say I should use spaces, who cares? There's another good rule to convince you, is that developers who use spaces make more money. And if you don't believe me, there's a Stack Overflow survey saying that from about 3-4 years ago. And this is not fake news. I'm not making that up. The links are on the references. You can check it out at the end. So if you don't want to use spaces, then that's okay. More money for me, for money for everybody else who uses spaces. The bottom line here is that using spaces pays off, literally. So another interesting anti-pattern is to not use else when appropriate with a loop. This is kind of tricky. I myself tend to reject this one a lot because it doesn't seem natural to me that an for loop have else statement, but in Python it does. And if you are also like me, you feel distressed when you see something like this, maybe just stay away from the code for a while, like 5 minutes, 10 minutes, go grab some coffee, look out the window. It's probably going to be a beautiful but cold day like today. But when you come back, you'll start to notice that the code, hey, it does seem better. You don't have to use an extra variable to check if you found what you are looking for. And the catch over here is that we actually need to use the break statement, or else it will enter the else part of the code. To not use get to fetch data from the dictionary. Python uses the approach of easier to ask forgiveness than permission, instead of the look before you leap, like Java and C. So the best approach for this scenario is usually to go for the get method, because then you don't actually have to check if a key exists or not in the dictionary. Python will automatically check that for you. And the default value that is returned is none. And if you're not actually satisfied by that, you can change the default value. On the right, you can see that it is returning an empty string. Using wildcard imports. So ideally, we should import only what is being used. And I know I said ideally. I'll get to that in a minute. Why that? Because among other things, using wildcard imports might make module names to crash from one library on top of another. For example, if we use from async.io imports timeout error is a very common and generic name. I think it exists, for example, in the requests library. So it's probably gonna get you into trouble into trying to figure out what's going on. And I know I said ideally before, we might be using a lot of modules, methods, and information from a library. If that is the case, we might be able to import, for example, a submodule instead of the whole module. To use the global statement, this is bad. It's okay if you use it for like maybe a quick script or something like that. But for production code, might not be the best idea ever. The variables are limited in Python due to the method scope or even the class scope. So the global statement is a bit something like, hey, I have these variables that they are not inside my scope, but trust me, they are outside. Just go look for them. And it works, but if you have lots of methods changing these variables, especially with something like async.io, then you're probably going to have troubles very quickly and very badly, maybe. And the solution is usually to encapsulate the variables into classes, then they are safe. Using single letters to name our variables, once again, this is bad, really, really bad. And for two reasons. First of all, like I mentioned before, in the built-in Python function, it hurts our debugging capabilities. This is actually true code. I stumbled myself onto something very similar to this twice, and I had a hard time into debugging specific methods. So we should actually use better names to improve our names description into our code. After all, everybody have a name. My name is Vinicius. My name is not V. And I'm not going to name my daughter or my son like A or B or Aux or Temp or any, I don't know, letter in the alphabet. So let's invest some time, not waste, invest some time into proper naming our variables, because we also gonna debug this code in the future, not just only us, but other developers. So let's help everybody out. Comparing things to true the wrong way, the code on the left works, but if you're actually checking for the Boolean type specifically, then we should preferably use the is statement. And a better explanation for this one, I have a few slides over here showing up with examples. We can see that one is true is actually false, which is maybe for those who never used the is operator, surprising. 1 equals true is true, just as 1.0 equals true. And on the right, I notice about the memory position for all these variables that were used. This is actually a good question for like interviewing processes, because in Python, we don't have to deal that much with memory management. So junior and sometimes even mid-term developers don't know about the ID method and memory management. So those who never heard about memory management in Python, I recommend you guys read a bit about it to understand how exactly does it work. It's very interesting. To use type to compare, we should actually use the is instance, preferably. So that is because is instance checks for inheritance. That means a derived class is also an instance of a base class too, while you type just check for the specific class. And finally, not using named tuples whenever it is possible. I hope everybody heard about named tuples at least once. If you don't, then I recommend you guys stop this talk and this presentation right now. Just kidding, please don't. We're almost at the end. And but named tuples are awesome, and you should check it out. And unfortunately, they are available just from Python 3.6 which is too bad for those who are still with Python 2. And the advantage for them is that when we use indexes such as 0 and 1, too much further in the code, we might have no idea exactly what that means. But when we use the dot operator like name.first and name.last, then it's very clear and easy to see and to read what exactly the code is doing. So that was about it I had prepared. Here are the references that I mentioned earlier during this presentation. And you don't have to notice them right now. They are available on the slides. They were already uploaded. And I hope you guys enjoyed a lot. Like we say back at ASIO, move to the edge. Obrigado, muchas gracias, vielen Dank, arigato. And I'm still working on the Chinese and Russian. I can't pronounce it yet. If you can, please do. If you have any questions at all, feel free to contact me into any of these means or on the platform for the convention. Thank you so much for the EuroPython Society for the opportunity to present again.
Yes, 谢谢你 is the thank you in Chinese. So yeah, there you go. 谢谢你. 谢谢你. Yeah. That's in Mandarin. It's not my mother tongue, so it's take it with a grain of salt, people. But yeah, thank you so much. It's very impressive, and also it's fun to know that we have so much anti-patterns in Python that I've never heard about that named triple, to be honest. So I have to leave maybe. But yeah, that's very interesting. So let me see if there's any questions in the chat. Yes, there's one. So is there any linter that check for most or any of these by default? So I'll also put the question.
Let's see. I believe PyLint will probably check for a few of them, like single variables or into single ladder variables. Let's see what else. Maybe going beyond the recommended method length or variable length. That's a bad thing, that linters, they cannot tell us all of these anti-patterns. They might catch a few of them, but pretty much just a few of them, unfortunately.
Yeah, I think in the worst case, you just have to sometimes, like I have a bad practice of like switching off the errors from the linter. So maybe if you really have to, you may have to do this. But yeah, so and then so among all these things that you introduced to us, so if you have to pick one that is most important and then we should really pay attention to, which one would you choose?
You mean the anti-patterns? I think.
Yeah, the anti-patterns.
I'll probably stick with the variable naming, because that bugs me a lot. It makes me distressed, like making the code harder to read, to understand. It's very annoying, at least for me. But a few of them can also be easily avoided. But usually when you get practice, like the God object, it's very common for anybody who's starting to make large projects with so many lines of code. And like I mentioned, if you stays away from 2 months away from your code, you're going to look into that, or maybe look into that in the future, like 5 years from now, and you're going to think, oh God, this is not good. Who made that? Crap, it's me.
Yeah. Sometimes I'll be like, who write this line, and git blame and see my name. I was like, oh God.
Yeah, nothing good comes from using git blame. It's either going to be you or a person who already quit the company.
Yeah, so it's just don't embarrass yourself. So yeah, that's very, very interesting talk. And then so if there's no more questions, I think yeah, I would just let you relax, and then maybe we can play some ads in between. But yeah, thank you so much. And then if people have questions maybe later, then of course people can find you in the chat, and then enjoy your Python. And I'll also pass it back to Nick to be the section chair as well. So
thank you.
Optiva is a global market maker. We provide liquidity in tens of thousands of financial products on major exchanges all around the world. Our engineers work to understand technology deeply and find simple solutions to complex problems, and Python is the perfect tool for that.
Okay, welcome back. I really like the ads. It's like we have the Python TV or something like that. So I hope everyone is enjoying the conference. I'm here to introduce Gina or Gina, and she will teach me how to pronounce that. I think I was trying to learn that in some rehearsal and I failed. So hello, welcome.
Yeah, welcome. Hi. Thank you. Thank you for having me. Yeah, it's Gina, actually. It's an Italian name, even though I'm German. So, parents
Gina,
are
I can do a bit better. Cool.
No problem.
So, where are you streaming from? Germany?
Germany, yeah. So I'm about, I don't know, maybe 10 minutes from Frankfurt am Main here. So quite central in Germany. And yeah, it's a hot day. It's a warm day. I went rock climbing this morning, so I'm perfect right now.
Right, that's super nice. I have a super important question for you. Is it space or tabs?
I do understand the ideas behind Tab 8, and so I have switched my code to spaces, but personally I've always been a huge fan of tabs, and actually tabs for indentation and spaces for alignment. That has always been my mantra, but I am playing by Tab 8's rules now, so yeah.
Nice. I really like. Now a lot of people will complain to you in the chat, so sorry about that. Okay, so Gina is going to be talking about driving 3D printers with Python, and she's a passionate code monkey gamer, hobby biker, and creator of and maintainer of Octoprint, and I think she's going to be talking about that. So I'm not going to steal more time for you, and thank you very much for being here in EuroPython presenting. And I hope we see each other next year in Dublin. So yeah, the stage is yours. Good luck.
Thank you. Okay, so yeah, as I was already introduced, my name is Gina Heuske, and I'm talking to you today about driving 3D printers with Python, and more specifically the lessons that I learned from that. Some words about myself first. Gina Heuske. The last name is actually usually making more people pause than the first one. I'm a software engineer, I'm a maker, I'm a hobby baker, 100% nerd, and I'm also in the happy position to be a full-time crowd-funded open source software developer. And I'm the creator and maintainer of Octoprint, which is also the project that I am working full-time on, fully crowd-funded. What is Octoprint? Well, it's the snappy web interface for your 3D printer. It's open source, licensed under AGPL v3, has currently something about 100,000 confirmed users, unknown actual number because the tracking is opt-in and GDPR conform and all that, so I only have a rough estimate there. The backend of this application is completely written in Python. The front end is your usual mix of HTML, CSS, and JavaScript, and you can find all out about this project on octoprint.org. Octoprint is, as I already said, an application, so something that users install themselves. And the target audience for Octoprint are, pretty much owners of consumer 3D printers. So the things that you can buy in your hardware, in the hardware store these days, actually, usually people who are makers and tinkerers who maybe want to print stuff for their miniature war games or terrain pieces or something like that, or who are into model plane flying and want to print parts for that, or who are just into 3D printing as a hobby. There are also some businesses here and there. So we are talking about end users, more or less, with some small exceptions. And these end users are rarely developers themselves. So we usually look at people who just take on a new hobby in the shape of a 3D printer, or who acquire a 3D printer for their business and they now want to drive it somehow, want to monitor it somehow. And this is where Octoprint comes in. Additionally, Octoprint targets, as the platform that it runs on, primarily targets small single PCB Linux computers, like, for example, the Raspberry Pi that you might have heard about. So small, cheap, $35 to $50, and easily just installed next to the printer with Octoprint on it, and then you are ready to go. Important is that while Octoprint primarily targets this platform, it still is platform agnostic. So if you still have a laptop gathering dust, you can also, if you desperately want to throw some Windows on there and run Octoprint from that. Or if you have an old MacBook, that also works. And this specific kind of target audience and platform restrictions, and also the whole thing that Octoprint is an application installed by end users and run by end users, and in a way then also maintained by end users, makes for some unique challenges, or at least I found them to be pretty unique. Because the literature is full about challenges for library development, but not so much about challenges for actual end-user-facing applications. And I want to introduce you to 3 of them that I encountered over the past almost 9 years now of doing this project. Challenge number 1 is initial installation and keeping things up to date. So I already said that Octoprint is installed on-premise by end users. So they download something and then have to install it themselves. Usually when you have some Python application, then you will just tell people that they just need to run pip install Octoprint, preferably also bootstrap a Python environment in the first place. And then they are good. But this doesn't work with the end users, with the audience that we're talking about here. What Octoprint instead does is that there is a pre-configured Raspberry Pi image that contains Octoprint, contains all the dependencies, contains the whole Python environment already set up with the virtual environment, with all dependencies installed, with a C compiler installed for compiling native extensions and all that. And users can just download that image, flash it to an SD card, and then boot it up, and Octoprint will then take it from there through a wizard and help them get started. So that has worked out really nice. The question, of course, is what about if you want to install it on something that is not a Raspberry Pi? Well, as I said, this is not the primary platform, so there will be some dragons, but it is in principle supported. There is a huge variety of encountered environments out there. So I've had people who have installed Octoprint on FreeBSD. I've had people install Octoprint on some old open WRT router that they still had lying around. Things like this. So that it can be very diverse and can pose some unique challenges actually with regards to dependency hell and all that. And that means that the code in Octoprint needs to anticipate some of these things. So for example, the IPv6 dual stack on Windows works entirely differently between compared to Linux from a Python point of view. And file locking works differently. For example, I cannot just, I do have to keep things in mind when I do something like log rollover or things like that in my client code, because yeah, things are just not working as easily under Windows because you cannot write a file that is currently in use. So these are things that you have to keep in mind there. And then you now have installed it. What do you do now? How do you keep things up to date? Again, the usual approach here is to tell people, well, just run pip install -u Octoprint and that will take care of that. But again, this is not really going to work out with the target audience here, because they usually don't even want to touch the command line, let alone run any kind of commands in there. So how I solved this in Octoprint is that Octoprint, as well as any kind of plugins that are installed into Octoprint, more on plugins a bit later, there is an update mechanism for those built into Octoprint, which itself is a plugin, by the way. But that basically takes care of this pip install -u in the background, gives everything a nice little UI. People get update notifications when something new is out, and they just have to click a button and everything will be taken care of them, making updating a very easy and straightforward appearance. So that is Octoprint. What about stuff like pip? You might have seen this message there when running pip install or pip update or whatnot. You are using pip version X, however, version Y is available. It turns out that this is a very scary message for end users, because they see a message that looks like something is wrong, something is broken, and it tells them something cryptic that they should be doing, and they don't really know how to do that. And yeah, that has caused a lot of support overhead. In the end, the solution to this was actually to hide the message in the update dialog and instead offer an option to update pip separately, but only for power users, so to speak. And the underlying operating system, Octoprint does not take care of that. Some users do update it, some don't. And the result is that we sadly also, once again, have to face a somewhat mixed environment, sometimes broken environment. It's hard to test. There's some additional support overheads caused by this. A lot of people are still of the conviction that never touch a running system is the mantra to go with these days. And I obviously do not agree. The only way to get people to actually install updates forever, at least in my experience, seems to be to tell them, here's a new feature, here's a bug fix. So that seems to work with motivating people to touch a running system and actually install updates in a very timely manner after each release. So lessons learned here is really try to control the runtime environment, but stay flexible enough so that you don't pretty much put people into a prison that you created. Make updates very easy so that that people will actually apply them, and also use features as a motivator for touching a running system and for getting people to apply the easy to apply updates in the first place. In short, really just enable them to keep their systems updated. Challenge number 2, maintaining backwards compatibility for a whole ecosystem. So I already dropped the word plugin here, and Octoprint has now sported a plugin system since 2015, since version 1.2.0. And we now are looking at over 300 plugins registered on the official plugin repository. Plugins do stuff like you get an email notification when your print is done, or fancy time lapses that make the print look like it is growing out of the print bed, workarounds for weird firmwares from 3D printer, from cheap 3D printers, and stuff like that. So we have a really established plugin ecosystem here now. And that means that suddenly Octoprint is not just a little application that I just write in my home office here, but it is pretty much become sort of a platform. And the platform requires stability. Why? Well, if I constantly change everything and throw APIs away and fire up new ones and make backwards incompatible changes all the time, I don't think that plugin authors would be as motivated to actually develop against this platform as they are now, which means I don't have an ecosystem anymore, which means the users that are drawn to the ecosystem, partially even more so than the convenience that Octoprint alone offers them, yeah, these users are now somewhat unhappy and disgruntled. So what does this mean? I actually have to spend a significant amount of time in Octoprint's update cycle on, pretty much going through dependency updates that I do need to do and check them for breaking changes, because it actually turns out that a lot of third-party dependencies regularly will break your code, even with patch updates. And the reason here is that even if I adapt my code for dependency changes, for backwards incompatible changes on third-party dependencies, if any kind of plugin now also uses the same version and does not anticipate this change, then stuff might break unintentionally on side of the user. Again, disgruntled user, unhappy user. We don't want unhappy users. So what I usually do here is when some kind of backwards incompatible change in an updated dependency rushes in, I look if I can somehow wrap it so that it becomes transparent for everyone using this code. Of course, it means a lot of work. It means a lot of version pinning. It means a lot of reading through changelogs and sometimes even commit histories. But it means also that there is a lot of stability on the platform. Another example where additional work and overhead is needed is code refactoring. If I spot a typo in my API, I cannot just fix that because someone might already be using this API. I have to think long and hard about any kind of changes in calling parameters or in return values or even just in side effects of certain commands, and that adds up. So usually that also means wrappers internally that make sure that every changes are handled transparently for any kind of calling code. And finally, the biggest challenge actually over the past years has been the whole Python 2 versus Python 3 migration situation. So as we know, Python 2 has been end of life since January 1st, 2020, but Octoprint for the longest time actually only supported Python 2, because I will admit that was a big mistake of mine when I created this back in late 2012. I simply did never anticipate it to become a thing. And then it became such a big thing that I never found the time to actually do the migration in a timely manner. So yeah, things took a long while, and now I also had to worry about the whole ecosystem. And this was pretty much my whole late 2019 and full on 2020 that I'm going to talk about now, which is migrating an ecosystem to Python 3. So how I tackled this with Octoprint was, I mean, it was absolutely clear that I had to make the cut at some point to at least make Octoprint compatible to Python 3. For now, it also still supports Python 2, but also try to push the whole community, the Python authors, the plugin authors, and the users themselves over to Python 3. And that needed a lot of preparation, apart from just rewriting parts of Octoprint or migrating parts of Octoprint. And the approach here was, first of all, a long preparation and briefing period. So while I was still working on the migration of Octoprint itself, I also worked with the community so that we could create some kind of migration guide. So I had some plugin authors work against the new version, work against Python 3, figure out the common pitfalls that they encountered during this, and then tell me about it and document all of that in a long document on the page. I also threw Python compatibility information in plugins and the plugin repository so that Octoprint would be able to look at a plugin's code and know whether it could even load that under Python 3 or not. So as to not cause any nasty surprises for users who would just try to load a plugin that is Python 2 compatible only under Python 3. I rolled out early preview versions of Python 3 compatible Octoprint for everyone, well, primarily plugin authors, but also end users to test against and see if everything was still working as expected, and if not, fix it in time and make it compatible to both. And I mentioned the plugin repository already. We also switched that to requiring newly registered plugins to support at the very least Python 2 and 3 starting in late 2019. If a plugin author decided they only wanted to support Python 3, that was of course also fine, but Python 2 only plugins were banned from a certain point. Then, just before the first lockdown in Germany, actually, I released Octoprint 1.4.0 that supported Python 2 and 3 on March 4th, 2020. The release went very smooth. The only problem was that some users were confused because they thought Octoprint was now only supporting Python 3, but that was a communication issue that thankfully was quickly handled with a FAQ entry. And since then, we've been more or less in ongoing migration mode. So users are asked to report any kind of incompatibilities with plugins that they discover with Octoprint running under Python 3 to the respective plugin authors so that they can migrate them and make them compatible. We also, the community, or rather someone from the community, also created a migration script that allows old image installs that still ship with a Python 2 virtual environment to be swapped over to a Python 3 image with, pretty much next to no input needed from the or action needed from the end users. So all they had to do was just enter one command into the command line, the scary one, and then everything got migrated, their plugins got migrated and all that. And that was really well accepted. And also we are, the community is now doing some motivation to get people to move over to Python 3 with their existing instances. By, first of all, we discovered that Octoprint is performing way, way better under Python 3. And also some plugin authors decided enough is enough and made their plugins Python 3 only. And that has also worked as a nice motivator. And because it's always nice to look at some fancy graphs when saying something like this, I've brought this. So this is the compatibility, Python 3 compatibility of Octoprint plugins that are registered in the Octoprint plugin repository. Sadly, I only have the data starting in May of 2020. And the yellow line is the amount of plugins that are Python 3 compatible. And you see that pretty much right after the launch, the release of Octoprint 1.4.0 with Python 3 compatibility in March, we were still somewhere around 33% or something like that. But there was a lot of growth because plugin authors saw, oh, there's suddenly a Python 3 compatible Octoprint version. We need to get stuff going now. And then I also discovered that the compatibility information for some plugins in the plugin repository was actually outdated. That was the first big jump there. The second big jump is the Python 3 migration script in September that I mentioned. Then there was also the release of the new the new Octopi image with Python 3 on board. And all of that has led to a steady growth. And we are now at something like 80% Python 3 compatibility in the ecosystem. I guess the rest, the leftover 20% are probably abandoned by this point. So once Octoprint switches to full Python 3 compatible only, Python 3 only compatibility, we'll know for good. Some of them will probably be adopted, and those who are not going to be adopted, well, might not have been as interesting. Okay, so lessons learned here is read change logs of dependencies if you can find them, and use version pinning to your advantage. You really do not want a third-party dependency to make stuff stop working for your end user somewhere in the field, which then do absolutely not know what to do here. Be prepared to work around breaking changes. Wrappers and sometimes even monkey patching can be your friend here. And most importantly of all is really just keep the ecosystem worth living in. Even with this huge migration with Python 2 to Python 3, we still have a lot of motivation by plugin authors to work in this system. And we still get users that are like, well, this plugin system is amazing and Octoprint is amazing. So apparently this has worked. And finally, the last challenge that I want to talk about briefly is performance. So we have one Python process here that has to serve a web interface and several clients connecting to it, also including over a WebSocket. Keeping a printer running, so constantly feeding it data, then plugins doing all of this as well. So this is a ton of stuff that is going on. And all of this is locked to one thread at a time, thanks to the global interpreter lock. If I had known about the global interpreter lock back in 2012 when I started this as a pretty much Python newbie, I would probably have chosen a different architecture. I mean, not Python, but a different architecture internally. But as things are now, I'm stuck with it. The problem here is that a lot of Octoprint's tasks are not I/O bound, but they are CPU bound. So checksums need to be calculated, or data needs to be processed, stuff like that. So it is not as easy to just say we can throw it into some other place and or just use async and everything will work fine. And thanks to data sharing with plugins, or rather between core and plugins being necessary, yeah, that also makes multiple processes a bit difficult, because now you also need to look at how you do actual data sharing and pretty much inter-process communication and things like this. And this is actually something that I still have not figured out. And as I said, if I had known about the GIL a bit sooner, or back in late 2012, as someone coming from the Java world, I would probably kept that in mind and designed accordingly, but now I have to somehow work around it. And this is still ongoing. And yeah, as I said, finally, the underlying platform, the Raspberry Pi or other single board PCBs, are usually somewhat limited in resources. Modern Pis have like 4 cores and up to 8 gigabytes of RAM, so it's become better, but still it's something where you really need to keep, yeah, every single change, with every single change, you have to keep in mind how it might impact performance at this point. So I'm not anymore in the comfortable position that I can just say, I'll just throw in this feature and everything will work as before, because features need additional resources, and that always means I have to think hard if I really want to do that. Yeah, lessons learned here. Look, that I made good experience with trying to actually extract CPU-bound tasks as much as possible into their own processes. So stuff like file analysis of the stuff that is supposed to be sent to the printer to look how big it is going to be and how much filament it is going to use and stuff. These are things that you can really nicely extract into their own processes. In general, be very conservative with resources, because even small changes can mean that it stops working efficiently for someone, and now their prints are no longer going through smoothly. And this is more like a to-do for me than a lesson learned. Explore IPC options and also maybe native bindings here and there. So I actually want to take a closer look at Python for that matter, and see if it can maybe help me in making some stuff a bit more performant, especially in the communication layer with the printer. And that already was my show. I want to thank you for your attention and for being here. Also, I want to thank the organizers for allowing me to be here. And if you want to get in touch or something, my Twitter handle is Fusel. You can also find me on GitHub under that and pretty much everywhere else. And my website is also fusel.net. And as I said, anything about Octoprint you can find on octoprint.org. Thank you.
Okay, thank you, Gina. That was really nice, super interesting. We have a few minutes and we have some questions, so I'm going to start asking those. So maybe we can reply. You can reply to all of them. So the first one is, people is asking if you are running the project alone, and they're saying, yeah, it seems like a lot of work. So they want to know if you have people contributing. Maybe they want to join. So
I don't have a small team, so I'm the only one who works on it full time. I have some regular contributors. I also have some very enthusiastic plugin authors and people who help me with all of the community management all around. But if you look at the commit history, I think it's pretty much still something like 90% or so that is mine, or maybe more. I don't know. I actually have not run stats on it, to be honest. But yeah, a lot of people think I'm at least 12 men usually, because, oh my God, a woman with an open source project, that cannot possibly be me. But no, it's really primarily just me.
Okay, so good time for everyone to take a look to your GitHub and help you. So the second question is, were you able to reach the plugin authors to rework the plugins for Python 3? And how long was the process of migrating the most plugins?
So the thing is that I do regular devlogs for the community called Octoprint on Air, and this is also where all of this obviously prominently featured, and a lot of plugin authors are watching these. So that was one way to reach at least the majority of them. A lot of them are also active on our forums and on our Discord, and that also helped in getting the word out, so to speak. And the rest then was actually done by the end user. So we had one plugin author actually write a little plugin that would flag all the plugins in someone's installation that were not Python 3 compatible. And then it even had a little button to open a GitHub ticket directly, which turned out to be not that good of an idea, because suddenly some plugin authors were swamped with 20 identical tickets that pretty much said, please update to Python 3. So that had to be changed again, but it worked nicely. So the crowd showed that it wants to keep using these plugins and actually help there. Yeah, and the migration seems to have been quite painless for most. Of course, some things are a bit tricky. So for example, if you do a lot, if for some reason you did a lot of string processing somewhere and did not really take care of the whole bytes versus Unicode situation, then that was quite painful. And yeah, I would have to look into the migration guide now, but there were some other pitfalls that really made people stumble, myself included. But that's thankfully now documented. So yeah.
Okay, so I think we have time for the last one. Maybe you were replying to that in your slides, but they were asking if using multiprocessing shared memory will help your problem.
Maybe. The problem is that the way that Octoprint itself gets started up has so far caused me a lot of gray hair with using multiprocessing. So I actually have not yet been able to get it to work without something breaking absolutely spectacularly. So I'm actually looking into an alternative, but yeah.
Cool. Okay, so we are just on time. So thank you very much for being presenting here. It's super important to have you, like speakers, in this conference. Otherwise, it's going to be super boring. And I hope I see you next year again. And for everyone else, if you want to continue the discussion or ask questions, you can go to WonderMe and talk using your cameras, or you can find Gina on the Matrix chat. So thank you very much.
Bye-bye. Thank you.
Okay, so welcome back. And now we are going to have the next speaker. And so I'm going to say welcome to Scott. Hello.
How are you?
I'm really good. Welcome to EuroPython 2021. Where are you streaming from?
I'm streaming from Brooklyn, New York, in the United States.
Cool. So what time is there? It's quite early for you, right?
It's about 8:15 in the morning.
Okay, nice. It's not so bad.
Not so bad.
Cool. How is the weather in New York? Now, it's summer like here.
Yeah, it's the usual hot and humid.
Okay.
Yesterday was about 30 degrees.
Okay, I don't miss that. I'm living in Amsterdam, and we don't have that in the summer here, so I think that's super good. I really like your T-shirt, by the way.
Me too.
Support by ladies. Thank you for that. So Scott is working for Bloomberg, and he's a senior engineer, a manager in Bloomberg, and he's helping also, of course, to develop Python applications, and he's also teaching internally in Bloomberg. So that sounds super good. And he's going to be talking about func tools. That's a lot of fun. So let's put your screen in the stage. Cool. So all yours. Good luck.
All right, thank you. So as I was introduced, my name is Scott Irwin, and I work for Bloomberg Engineering. And today we're going to talk about a hitchhiker's guide to func tools. And it's kind of interesting that I proposed this talk at the very beginning of June. And thank you for the conference organizers for accepting it. And about 3 weeks later, Martin Hines wrote a blog post pretty much about func tools and all of the wonderful features that are in there. So there's something sort of in the Python zeitgeist that is generating interest in what has actually been around for a while. So this is not going to be in depth in any one aspect of it. So several of the aspects you could spend a whole conference talk just on that one thing, but this is more just an overview to give folks an idea of what's there for further investigation within your own projects. So what we're going to cover is we'll talk a little bit about definitions and histories, but that's very quick. And then we're going to get into the substance of func tools. We'll talk about simplifying function signatures, function wrappers, caching. We'll touch on ordered types. We'll touch on reduce, and we'll actually introduce this concept of function overloading in Python. For those of you who are coming from maybe a different language and you heard that Python doesn't support function overloading, that's not completely true. Python does have a way of supporting function overloading via the func tools module. And then we'll wrap up, and I'll include some references, including a link to Martin's blog post. So quick definition and history. So the Python standard library module functools contains several higher order functions. So what does that mean? What is a higher order function? So they are functions which act on or return other functions. So basically they take a function as an input or they return a function as an output. A higher order function that many of us are familiar with are function decorators. That is an example of a higher order function. Just a quick history on functools. It was actually added back in Python 2.5 in 2006, and its initial members of the module were wraps, update wrapper, which those two are very closely related, and partial. Additional functionality was added. Reduce was added in Python 3.0 and backported to Python 2.6. Total ordering and comp to key, which we're not going to talk about at all, was backported to Python 2.7, plus LRU cache was added. 3.4 brought in partial method and single dispatch, and Python 3.8 brought in cached property and single dispatch method, and most recently Python 3.9 brought in cache. So you can see that this module is evolving over time, and it is continuing to evolve even in the newer versions of Python. So simplifying function signatures, and what that basically means is partial and partial method. So partial is a function that takes a function as an argument, and it takes a set of arguments, both positional and keyword. And those inputs are essentially locked in arguments to the function. And then partial returns what's called a partial object, which behaves like the original function with those arguments already defined. And so that's a lot of words. Let's look at a quick example just to get a sense of what that is. So here in the example below, we're taking the function pow, and we're essentially predefining the exponent to be 2. And so we're taking the return of that and creating a new function called pow2. And here in the example, we can see if we pass pow2 just the single value 5, that we end up getting 5 squared, or 5 to the power of 2, the value 25. And so this is just a quick example, but where you would really want to use partial is to transform multi-argument functions into a single argument function in places where it's required. So an example here is map. Map requires only a 1 argument function, but what if you have a 2 argument function or a 3 argument function that you want to use in map? It's possible without partial, but it ends up being much more verbose. So here are some, at the top here, we have the example with partial, and you can see that it is relatively compact and fairly straightforward to read. So I'm doing map on pow with an exponent of 3. I can just kind of read that across. The list here is just because map returns a generator, and I just wanted to realize the results of that generator. I could do the same thing by defining an external function and then using that external function in map, but this is like 2 extra lines of code, and where it's actually used, it's not exactly clear what this pow3 is. So imagine that the pow3 is defined in some other place distant from where it's actually used. Now I don't easily know what this thing is about. I could also use a lambda, which kind of brings the definition close to the use, but there's a lot more typing here, and it's not 100% clear what is going on. So the partial just becomes a way of creating something that is a little cleaner and a little easier to read. I can also use partial to simplify code. I can use it to define functions that are easier to type, read, and importantly, friendly to code completion. So here I'm using partial to define a function called print standard error, where I'm just using the built-in print function, but I'm setting the output to be standard error. So now when I want to print something to standard error elsewhere in my code, I can use this print underbar standard error. And because this is defined as a function, when I'm in my editor, I can do code completion on print underbar standard error. It'll be available, and it just makes it simpler and easier to use, where I could use print open paren file equals blah, 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 but that's a lot more to type in every place I want to use it, and it's not very friendly to code completion. Closely related to partial is partial method, and the easiest way to think about this is that it's partial for class methods. From the Python docs, it returns a new partial method descriptor which behaves like partial, except that it's designed to be used as a method definition rather than being directly callable. The function that's in the argument here in partial method must be a descriptor or a callable, but all that really means is that if you have a method in your class, it fits the bill. So here's a quick, this is lifted directly from the Python 3.9 docs. There's nothing very original here. But I have this class cell, I have a property called alive, and I have a set state for that property that will take a Boolean, either true or false, to set the state of the cell to be either alive or not alive. Now, I can use partial method then to create these two convenience methods, set alive and set dead, that just basically predefine the true or false for set state. And now inside, in this case, a REPL, but also in terms of code completion, I now have this set alive convenience function available to me that I can just call and use without having to type out the more verbose implementation. So that's simplifying function signatures. Now let's move on to function wrappers, which is wraps and its closely related update wrapper. So wraps takes a function that it's wrapping or that is to be wrapped. It's a function decorator used when defining a wrapper function. It updates the wrapper function's attributes to be the same as the wrapped function. And as I've alluded to, it's a convenience decorator factory for defined using update wrapper. So it's basically it's syntactic sugar for update wrapper. So if we didn't have wraps, what we would end up with something like this. So I have my decorator, I have a wrapper that's defined within that decorator, and I use that to wrap a function. But when I call that function, the wrapper is called, then the function's called, then that's fine. Everything functionally works. But when I look at the function name, it's this function up here, wrapper. It's not the original func. So where this is important is like in stack traces or in error messages. It's gonna be confusing as to where the failure actually is. Also, the doc string is picking up the wrapper's doc string and not the original function's doc string. So if we use wraps, it just becomes a decorator on the wrapper function itself, and it takes as input the original function. And so now, functionally, everything still works the same. The wrapper is called, the function's called, but now the function name is what I expect. It's the original function, and the doc string is coming from the original function. And so this is just to make my code behave more like what I would expect it to be. Update wrapper is rarely used directly. It updates the wrapper function attributes to be the same as the wrap function. It's useful in situations where the decorator wraps cannot be used, such as wrapping a function after it's defined or wrapping a function you do not own. So here's a quick example. I'm grabbing from the string library the standard library function cap words, and I'm wrapping it in this thing called my cap words. And when I call my cap words, it works like I expect. But the name of the function as well as the doc string is quite long, so I didn't include it here. It's not it's referencing mine, but maybe I want it to behave in the context like it is the standard library cap words. So here I can use update wrapper to take my original function and say, all those function attributes, just make them the same as the original string.capwords. And so now if I look at the name for string.capwords for the local capwords and my capwords, they all are the same. And if I call the capwords, it ends up calling mine. Something important to note here is update wrapper, in addition to doing this work, will return essentially a reference to the function that I can then use later, which is what I'm doing here. Caching. So there's a couple of different features of caching in the functools. The first one is LRU cache. These are its default arguments. It wraps a function with a memoizing callable. It saves time when an expensive function is sometimes called with the same arguments. It caches the results of the most recent max size calls. So in this case, the default is 128. So that cache will hold up to 128 entries. LRU, by the way, stands for least recently used. So as something more recent comes in, the oldest one gets kicked out. If typed is set to true, the function arguments for different types will be cached separately. So if you have a function that takes a number, integer 3 would be cached differently than the floating point 3.0. Otherwise, they're treated the same because they're equivalent values. The LUR cache, when you create it, has some attributes. It has cache info, which will tell you the current state of the cache, like what's in it, how big it is. It has a cache clear method, which allows you to clear out or invalidate the cache. And it also has a cache parameters method, which will return a new dict. So you can't use it to modify the value of the cache, but it'll basically tell you how it was instantiated. What was the max size and type used to create this LRU cache? Here's a quick example. This is a fairly standard example. So I have a Fibonacci, and as those of you that have seen this before know that with bigger and bigger numbers, it gets more and more expensive because I'm making all of these recursive calls. So what I do is I put an LRU cache on it. And what that means is that I can calculate out to fairly large numbers. But Fibonacci, to calculate, say, for the Fibonacci value for 10, I calculate the Fibonacci value for 8 and 9. Well, because of the way we've done this, we've calculated it for 0, for 1, for 2, so on and so forth. So by the time we get to these larger numbers, we've pre-calculated all the smaller ones, and they're now sitting in the cache. So this runs fairly quickly, and what we can see is that we have 28 cache hits. 16 misses is basically means that the first time it sees each number, it doesn't know what the value is, so it has to calculate it. The max size, we got the default of 128, and it has 16 entries, which is the values for 0 through 15. And here we can see what the cache parameters, even though we didn't define them up here in the decorator, we just got the defaults. And we can see what those values are. Some caveats with LRU cache. The function's positional and keyword arguments must be hashable, which means that it can't take things like lists or mutable classes. The underlying storage for the LRU cache is a dictionary. And so those function arguments are used as a key into that dictionary. So that's where this requirement is coming from. It should only be used with pure functions. What that means is that the same inputs always produce the same output, which implicitly means that the function that you're caching should not have side effects. It shouldn't write to a database or do something that would mutate the system. Closely related to LRU cache is the recently introduced cache, and this is just a simple, lightweight, unbounded function cache. So it's the same as LRU cache with no maximum size. Because there's no eviction, because you never throw anything away from the cache, it can be written in a way that makes it smaller and faster compared to LRU cache with a size limit, because you never need to compare about, have we hit the cache limit? What do I need to do? What's the oldest one? So all of that logic goes away. The caveat with that is that if you're using it on something that takes a very large variety of inputs, you can end up with a very large cache. So use that one with caution and forethought. Related to these two is cache property, which is similar to property with the addition of caching. The value is computed once and then cached as a normal attribute for the life of the instance. Unlike property, cache property allows writes without a setter method being defined. Cache property only runs on lookup and only if the attribute doesn't already exist on the object. Once the attribute exists, subsequent reads and writes work like a normal attribute. So quick example here, we're taking in a sequence of numbers, we're storing it as a tuple of a sequence of numbers, so now we know that that sequence is immutable. And then essentially we're gonna add a cache property standard deviation, which will return the standard deviation of that sequence of numbers. So here, I wanted to give you a sense of like what that cache property buys us in terms of time. So I'm taking a very large sequence, 10 million, and I'm calculating that standard deviation on that sequence. The initial one, it's a little hard to read here, but you can see that it started at, call it 11 seconds and finished at 39 seconds. So it took somewhere on the order of 28 seconds to calculate this standard deviation. The very next time I call it, I still get the same answer, but now it took somewhere in the milliseconds to get that answer. So it's basically just a property lookup. So for things that are expensive to calculate but don't change once they are calculated, this is a very handy thing to have. We're going to just briefly touch on order types using total ordering. Total ordering is a class decorator that makes it easy to create well-behaved, totally ordered types. If a class defines at least one rich comparison operator, it will the decorator will supply the rest. So what that basically means is that you need to define one of these four: less than or equal, greater than, or greater than equal, and the class decorator will generate all the rest of them. Additionally, the class should supply an equal operator, though that is not strictly necessary. One caveat with this is it does come at the cost of slower execution and a more complex stack trace for the derived comparison operators, because essentially they get defined in using the one that you defined as its implementation. So here's a quick example. I created this car class. It takes year, make, and model. And I define equal and less than, and that's it. And these are just relatively simple comparisons on year, make, and model. And so what this shows here is, though, even though I only define the less than operator, I'm getting the greater than operator for free. And I'm getting it because of this class decorator, this total ordering. One more that we'll touch on is reduce. Reduce takes a function and an iterable, and it applies that function of 2 arguments cumulatively to the items of the iterable to reduce it to a single value. That's a lot of words, but if you've ever used the sum function, this is an example of a reducer. Well, Python has a built-in sum function. It doesn't have a built-in product function. So here we can use reduce to implement a product function. So we take reduce, we give it the operator mul or multiplier, and it takes an arbitrary iterable and it has an initial value of 1. And so now I can call product on a list, a range, or any other iterable, and it will just multiply them all together in the same way that sum adds them all together. And so this can be a handy thing to use for these kinds of situations. The last one, and this one in particular, could occupy a 25-minute talk all on its own. And this is single dispatch. This is where we get into function overloading. Single dispatch is a function decorator which takes a function, transforms it into a single dispatch generic function. This means that the implementation is chosen based on the type of the single argument. So you have a different function for, say, integer versus a string versus a float versus a list versus whatever. The overloaded implementations are decorated with a register attribute, so that when you call the function, it knows where to find the implementation. If the implementation is annotated with types, the decorator will automatically infer the type of the argument. Otherwise, you have to declare what the type is in the decorator. So what does that look like? So here I have a function, fun, that takes an argument. This is my generic function. So this is in some sense the default implementation. So now I register a function, and notice here I'm not even bothering to name it. Its name is immaterial. It's going to be an implementation detail for fun when it's called with an integer argument. I'm going to also register it with a list argument. And then just to illustrate, these are both using type hints, where if I don't use a type hint, I have to declare the type up here in the function decorator. So now I've defined my generic function. I've defined it for an integer type, for a list type, and a complex type. So if I call it with an integer, I get the results of the integer implementation. If I call it with a list, I get the implementation of that. If I call it with a float, I get the default implementation because I haven't provided essentially a type-specific version of the function. And if I call it with a complex number, I get the complex implementation. Single dispatch method is the same thing, but for class methods. It's a function decorator which transforms a method into a single dispatch generic function. The dispatch happens on the type of the first non-self or non-class argument. So that implies that you can use it both on object methods and on class methods. So with that, we're going to wrap up. So the functools module contains many higher order functions which are both useful and powerful. And using these functions can result in more readable and more maintainable code. Some references. Of course, the Python language reference is an excellent place to start. These slides are available on GitHub at the link that you see here. It's in my GitHub repo, SJ Irwin. As I mentioned before, Martin Hines wrote a blog post pretty much on the same topic called FuncTools, the Power of Higher Order Functions in Python. There's a somewhat more, I think this one is from 2020. Florian Dalitz wrote a blog, very similar, Introduction to Python's FuncTools module. So between these 4 pieces, this should get you more interested and more informed on FuncTools. And with that, we're done.
Okay, thank you, Scott. That was really a lot of information. I was learning a lot. I know, but there was a really important, like I was seeing in the channel, like a lot of people saying, yeah, today I learned something, right? Like I like FuncTools is like ITER tools, right? Those 2 documentation pages on they are really good. Okay, so I have a few questions.
Sure.
The first one is, will using partial method for the examples, set alive and set dead, so there was 2 examples that you were using, actually be Pythonic? Would it be used in production?
So I would argue that they would be Pythonic because they are lifted directly from the Python documentation themselves.
That's a good answer.
It's a way, if you didn't use that, you would end up having to essentially write a little 2-line function that implements that. I mean, it would be relatively straightforward to write, but now you're being more verbose than you need to be.
Yeah, fair point. Okay, so I have one more. I'm checking the channel if someone is, and this was me, so I'm cheating. But yeah, I'm a volunteer, so I can ask questions. Sure. Yeah, what's your favorite FuncTools tool?
So probably based on slide count, you can guess that partial is one of my favorites. Yeah. But in terms of like most useful, I think I use @wraps more than anything. If you're writing decorators, you pretty much need to use @wraps.
That's true. That's true. And then yeah, I think we're okay. Could we define product with reduce to be in the scope in the tag? Let's talk.
Could we define product with reduce? I think I'm a little confused on the question.
Yeah, me too. I was just copy pasting that, so maybe that person can.
Yeah, I'm happy to answer the question, but I don't think I fully understand what.
Me neither. Let me see. Yeah, maybe. Oh, maybe the question is if you can define product using reduce, I think.
Oh, could you use map to achieve the same end result? Yes, you could use map to achieve the same end result. The main idea behind using reduce is it's just a little cleaner and easier to read what it's doing. Also, if you're coming from a functional programming background or you've worked with functional programming languages, reduce is going to look very familiar.
Yeah, that's true. Okay, and I think I have one more. Wait. Oh no, that was just people interacting. So that was the last one.
Okay, excellent.
I will tell you, but if you want to keep talking with Scott, you have 2 options. You can go to WonderMe, Scott, and see if someone reaches you there, or you can just stay in the breakout room, Brian. I'm sure people will be asking you more questions. And again, thank you very much for being a speaker in the conference.
Thank you for having me.
See you next year.
See you in Dublin.
Cheers.
Cheers.
Optiva is a global market maker. We provide liquidity in tens of thousands of financial products on major exchanges all around the world. Our engineers work to understand technology deeply and find simple solutions to complex problems, and Python is the perfect tool for that.